So I'm going to talk on dose rate effects and in particular on the DDREF and the actions ICRP and Committee 1 have initiated. Now if you look through the literature and read on dose and dose rate effectiveness factors, then the terminology is very confusing. You find a lot of different terms. Sometimes you read a paper on the low dose effectiveness factor, LDEF, which is sometimes called DEF, as I learned today from Julian. Dose rate effectiveness factor, linear extrapolation overestimation factor, and so on and so forth. So it's very, very complicated, if you wish. And today I just would like to talk on the first two and use the first two terms. For example, the LDEF, the low dose effectiveness factor, you can address if you investigate exposures to various doses of acute exposures and then analyze the curvature of the dose response curve. As far as the dose rate effectiveness factor is concerned, you can compare, for example, cohorts exposed with high and low dose rates, and then you get an idea on the dose rate effectiveness factor. Just to remind you on the definitions, Julian has already shown that the LDEF you can define, for example, if you start with a linear quadratic dose curve here, alpha d plus beta d square, a linear term and a linear quadratic term. And then if you, for a certain dose dx, calculate the slope of this line here, it's just alpha dx plus beta dx squared divided by dx. And then if you compare that to the slope of the initial curve, then you get the LDEF. That's the ratio. Now the dose rate effectiveness factor, if you again start with the linear quadratic dose response, acute exposure, and then introduce fractions. For example, the black curve here has 3 fractions. And then you see that the dose, the shape of the dose response becomes less steep, let's call it like that. This is the curve for 6 fractions, for 9 fractions. And if you use infinite fractions, that is a chronic exposure, then the resulting dose response curve is linear and the slope of this curve is the alpha term. So in principle, theoretically, the DREF is very close to the LDEF. And ICRP, this is one of the reasons why ICRP has decided earlier to combine those two factors and introduce the DDREF, dose and dose rate effectiveness factor. But this holds, of course, and we already heard also about this by Julian, if the alpha term does not depend on dose rate. Okay, the last slide of my introduction, what is a low dose rate? Just to remind you about some basics. For example, if we are here at ICRP, the ICRP proposes a dose limit, annual dose limit for workers, 20 millisievert effective dose per year. And if you just assume 2,000 working hours, this would correspond to a dose rate of 2 times 10 to minus 4 per minute. Just to give you a perspective. Or the natural exposures are of the order of millisievert. In the US, we learned, I think 2 days ago, it's 6 millisievert effective dose per year. In Germany, it's 4. So, but just if you assume some millisievert per year, this would correspond to 2 times minus 6 millisievert per minute. So these are the dose rates we are talking about in radiological protection. And UNSCEAR 2012 defines a low dose rate as less than 0.1 milligray per minute, averaged over 1 hour, and we keep this definition here. And what is a low dose? And here I would like to remind you or come back to the lifespan study, to the most recent data produced by RERF for mortality. And I took this picture from a paper of Dr. Osaza. You see here the excess relative risk as a function of weighted colon dose. And if you look at for all solid cancers together, if you look at the dose response curve, then you see that and you understand that, and this is written in the paper of Dr. Osaza, that if you look at the dose range between 0 and 0.2 gray, then that's the first dose range where you can find a statistically significant excess relative risk per gray. And so UNSCEAR defines a low dose, a dose of less than 100 milligray, and we keep with this definition. Okay, so what do we know about DDREF? And I looked through the UNSCEAR reports, what the UNSCEAR reports historically say about this topic. And let's start with report number 1 from 1958. And there the report mentions opinions as to the possible effects of low radiation levels must be based only on extrapolations from experience with high dose and high dose rates. And although we nowadays know much, much more about radiation action on biological systems compared to in the year 1958, the situation is still the same. So we have to extrapolate from higher doses and higher dose rates down to lower doses and lower dose rates, which are relevant for the radiological protection setting. Now, 4 years later, UNSCEAR stated, because data from the atomic bomb survivors was still limited, that animal experiments are important. However, their usefulness was judged limited by the difficulty of making valid extrapolations to man from animals. And again, we face with this problem even today. In 1969, where cytogenetics already allowed to measure chromosome aberrations, it was found that both chromosome aberrations and tumors increased with increasing dose, but it was noted that the relationship between the two effects is complex. And again, we face this problem even nowadays. Well, for the first time in 1977, UNSCEAR introduced numerical values, suggested a range of numerical values for those reduction factors, and they said it's between 2 and 20. NCRP in the US introduced in 1980 the dose rate effectiveness factor, DREF, and they said it should be between 2 and 10 based on animal models. So the range of values is pretty large, or was pretty large at that time. And it was stated in UNSCEAR 1988 that if you apply such a factor, you should also keep in mind that it might vary with different tumor types, for example. So it's really a very complicated situation. And again, between 2 and 10. And then it was in ICRP 60 in 1991 that the DDREF was first defined, the dose and dose rate effectiveness factor, and ICRP suggested a value of 2. UNSCEAR followed this approach and this proposal 1 year later. They suggested also a value of about 2 for the DDREF, but acknowledged, and this was also acknowledged by ICRP, of course, that there is quite a large uncertainty with this value. And ICRP decided to use one value just to make sure that the radiological protection system is practicable, simple enough to be applied in practice. Now, about 10 years ago, UNSCEAR 2006 introduced a new approach. So they did not apply a reduction factor whatsoever, but they used the whole dose range and information of the whole dose range available from the lifespan study data. And in this way, implicitly, because they followed the shape of the dose response curve down to lower doses, they implicitly took into account the LDEF, the low dose effectiveness factor, and they said, okay, this approach is consistent with the application of a DDREF when extrapolating from high dose and dose rates to lower dose and lower dose rates. Bear 7 in the same year came up with a more precise number. For the DDREF, they suggested 1.5, and the uncertainty range is already quite rather small, actually. And they based their judgment on both on animal experiments and human data. I'll come to that later. ICRP 103 confirmed that a DDREF of 2 should be used. And then more recently, the WHO report, the Fukushima report, used a DDRF of 1. And UNSCEAR 2013 commented on that this is not incompatible with the committee's estimates of cancer risks, and also it's not incompatible with the data from the lifespan study. So there is a, yes, and the last one is the SSK report, which came out last year. It's a dedicated report to DDREF. This is the German Radiation Protection Commission, and they discussed the scientific principles behind the animal, molecular cellular data, animal data, epidemiological studies, and radiobiological models, and also included a discussion on more operational criteria, such as the influence of uncertainties, the practicability of the radiological protection system, and so on and so forth. And they came up with the conclusion that they recommended abolishing the DDREF, or at least adjusting it to bring it into line with more recent findings. And all the other parameters pertaining to the detriment should also be adapted to latest scientific findings. And I should mention, DDREF, if you look at the radiological protection building, is just one piece of a much bigger picture. There are a lot of parameters that could also be revisited if one decides to revisit the DDREF. And SSK also urges that an international agreement is necessary, that it doesn't make sense just one country to change certain DDREF. It should be an international consensus, and ICRP is obviously the forum or the organization that should take the lead in that. So there is, obviously it seems there is a trend of decreasing values for DDREF with time over the decades, and this prompted ICRP actually to set up a task group within Committee 1 to look at that. It's TG91, radiation risk interference at low dose and low dose rate exposures for radiological protection purposes, use of dose and dose rate effectiveness factors. And you see here the names of the full members and the corresponding members, and we tried within Committee 1 and to include all expertise available internationally to tackle this problem. Now, what is the status? What is the task group doing? And one important event took place just a couple of months ago. This was a task group meeting between members of the task group and Japanese experts. So the task group met in Kyoto in May. I met Japanese experts and discussed the problem. And this is one example how ICRP tries to involve stakeholder opinions already at the state of task group work. So there was a session on information from ICRP where a number of task group members gave presentations. There was a second session with presentations from Japanese scientists. And I should also mention that the whole workshop was chaired by Nobuhiko Ban. He's a member of Committee 1, so that on the one hand. And on the other hand, he's a Japanese expert, so he was the perfect chair for this action. And there was a third session on discussion, to discuss the DDREF issue. And a number of questions were addressed during this workshop. For example, should DREF and LDEF be separated or combined to one factor, to a DDREF? I will not go into detail what the discussions, what the results of the discussions were, but the final result was, well, the task group should indeed have a look on the scientific level first, whether there is evidence to distinguish between low dose and effect factor and dose rate effect factor. And you heard already from Julian in the first talk of this session that there is some evidence, there might be some evidence. The second question which was discussed, should a DREF also be applied to leukemia? And as you might know, ICRP does not recommend to apply a DDRF of 2 to leukemia because it was felt that the linear quadratic dose response used already includes implicitly the low dose or low dose rate effect. But from the discussions of the workshop, it turned out that maybe one should nevertheless have a look at dose rate effects among leukemia as well. Next question, how robust are the scientific results obtained from human epidemiological studies in low doses and low dose rates? Then there were questions about animal studies, how variable are other factors besides radiation? There was a question, are animal data applicable to humans? So the question which we heard already in one of the first UNSCEAR reports, still topical. Which endpoints are relevant in radiobiological studies? So there was a lot of discussion, and I will not give you all the details of the discussion here, but if you wish, if you are interested, there is we prepared, all the participants in the workshop prepared a workshop report, and the workshop report is now already published in Radiation and Environmental Biophysics, and there you can find all the details of these discussions. Now, what is the task group doing at the moment? For example, Dr. Buffler from PHE in the UK, he's also here, a member of C1. He already performed a review of molecular and cellular studies, and he focused on the following endpoints: on DNA double-strand break induction and repair, gene mutation studies, chromosomal aberration studies, and thresholds for cell cycle checkpoint activation and apoptosis. And the very provisional conclusions is that cellular data indeed tend to support application of a DDREF, and typical values, you can interfere, Simon, if you don't like this, what I'm saying. So this was what I understood about a factor of 4, but one should keep in mind, if you look at those data, cellular molecular data, that much time elapsed between induction of gene and chromosomal mutations and the clinical presentation of cancer, many years and even decades. And during that time, many processes are likely to modulate this, and we may even don't know some of these processes, but they could together have a significant influence on the numerical value of DDREF. Now, after the workshop in Kyoto, we understood that the task group should broaden the review a little bit, and Simon agreed to also look at the question and evaluate the radiobiological evidence for treating dose and dose rate effects separately. So this was one outcome of the Kyoto meeting, that we should do that. Then we have evidence from animal studies, and Gail Woloschuk from the US is in charge of this. Gail Woloschuk is from the Northwestern University, and she is also in charge of the Janus database, where all the animal data in the US are collected at the moment and stored. And what you should keep in mind that the Bear 7 report 10 or 9 years ago, they used animal data, but they just used one data set from Oak Ridge. And this was the best what they could do at that time. But nowadays, with the databases available, one in the US, the Janus database, there is another one in Europe, one can have a look at many more data from historic mice animal experiments. And so she already started looking at those larger data sets, and with respect to dose rate effectiveness factors, and a first paper of this action already appeared a few weeks ago in PLOS ONE. So you can read a bit more details in that paper. And for the future, so most of the studies so far were based on life shortening as an endpoint, but one could also look at other endpoints, such as tumor incidence, for example. One could also look at other species, not just mice, rats, dogs. There are a lot of data available. So in the 1960s, and a lot of animal experiments were carried out. Human data, we have done a review of major cohorts for epidemiologic low dose rate studies, and Roy Shore from the US, former RERF, he did that already. So he reviewed the data on solid tumor risks, total cancers, but also on selected cancer sites, breast, lung, colon, stomach, and liver cancers, and did a PubMed literature survey. And altogether, he identified 22 studies that could be used and compared to the lifespan study, which is a high dose rate exposure, of course. And there are detailed tables already available describing these cohorts. And these tables are available for the separate endpoints as well, for the separate cancer cases. And this was a bit on hold because we wanted to wait for the results of the INWORKS study. The INWORKS study is a combined study of nuclear workers from the US, UK, and France, about 300,000 individuals. And you may have heard that this study just came out and was published yesterday. So now we can continue, including the INWORKS study, and do a meta-analysis of the data. And the meta-analysis to deduce a dose rate effectiveness factor from the epidemiological study is currently being done by Linda Walsh from Germany. The idea is that if you look at the various cohorts identified that are suitable, then they have, of course, different age distributions of the individuals in the cohort, for example, as sex distribution. And the idea is to use those distributions and then go to the lifespan study data and match those data with those distributions. And then you can directly compare the risk coefficients from the lifespan study, which is a high dose rate exposure, to those from these studies, which are low dose rate exposures. So that's the idea behind, and the methodology is already fixed, so Linda is ready to do that. And again, we wanted to wait for the INWORKS study, but the data are out now, and so we can continue that. And the other thing, which will also be done in the future, is to do a similar search and a similar analysis, if possible, with the leukemia data. And this was also an outcome of the Kyoto workshop with Japanese scientists, if you remember. Okay, then this was how to identify information on the dose rate effectiveness factor from human data, from epidemiological cohorts. Of course, we can also deduce information about on the low dose effectiveness factor from human data. For example, if we analyze the dose response curve of the lifespan study of the atomic bomb survivors, and Mark Little from the US is currently doing that. So he uses the data from the latest mortality study of Dr. Osaza, and is currently using various models and tries to understand or tries to analyze the shape of the dose response curve to get an idea on the low dose effectiveness factor among that data, depending also on the cutoff, the dose cutoff. It depends whether you use the whole dose range or just dose range up to 2 gray or even less. This is one issue, and the other issue is that Mark is going to redo the analysis which was done by UNSCEAR in 2006, which I mentioned earlier, if you remember. And you might also know that Mark was the lead author of this report in 2006, as far as I know. So he is going to redo that analysis now with the most recent data, and then we will see how this approach fits to the ICRP approach. Okay, let me come to the summary and outlook. First of all, it's important to understand that DDRF is a moving target. It depends on the current scientific findings, and science is proceeding, so we know more and more. And from time to time, one has to relook and reanalyze the scientific evidence for this. And this is currently being done by ICRP, TG91. And we are scrutinizing biological studies at a molecular and cellular level. We also would like to go beyond BR7 as far as the animal data is concerned, to look at a broader data set of animals, which is now possible. And we are going to do a meta-analysis of solid cancers, and if possible, we will look also at the leukemia data and analyze the dose response curves, linear versus linear quadratic models, and discuss also further methodological aspects. Thank you.